Hi everybody, today we're going to find the equivalent capacitance in a circuit. We'll use the circuit on the right to find the equivalent capacitance of the circuit. When we're done, we'll round our answers to 2 decimal places. Notice we have 2 capacitors that are in series along with 1 capacitor that's in parallel. Let's take a closer look at the capacitors in series. Capacitors combine in series like resistors combine in parallel. We have 2 ways we can find their combined capacitance. We can find the equivalent capacitance by finding 1 over C equivalent is equal to 1 over C1 plus 1 over C2. That would be 1 over 8.6 plus 1 over 6.6. 1 over 8.6 plus 1 over 6.6 gives us 0.26779. Because the 0.26779 is 1 over the equivalent capacitance, we need to flip that number over. We can easily do that by using an exponent of -1. So back in the calculator, I'll hit the x to the -1 and tell it to give me that answer as a decimal. This gives me 3.734. Let's look at another method. If I only have 2 capacitors in series, I could use this shortcut. I could multiply the 2 capacitance and then divide by the sum of the capacitance. So for our example, that would be 8.6 times 6.6 over 8.6 plus 6.6. Let's try that in the calculator. I'll clear everything out. I'm going to use a parenthesis to say that numerator is 8.6 times 6.6. I'll close the parenthesis to say I'm closing the numerator. I'm going to divide by and again do a parenthesis. This time I'll do 8.6 plus 6.6. I'm going to push enter, which again gives me the 3.734. This might be a little faster, so pick the method that works best for you. Now we're ready to go back and look at our entire circuit. We'll add in the capacitor that's in parallel. Capacitors in parallel combine like resistors in series, which means we just need to add the 5.6 to our 3.734. This gives us a total of 9.33, and as always, don't forget to add your units to your final solution.